So much work and research has gone into making storage systems for servers fast and nearly foolproof. Naturally, we are hinting at high-speed disk arrays where if one or more drives goes down, then the others with the same or redundant data keeps running. The most common type of reliable high-speed storage system is a shared disk resource, or a SAN, which stands for Storage Area Network. The SAN is often so reliable that unless there are natural disasters or some power failure, then the SAN will stay up and running. In fact, it is more likely that the CPU itself will have hardware or power failure and the storage will still be available. Also, regularly scheduled maintenance will cause you to have to reboot the server occasionally, but the SAN won't go down. Any downtime where your server was not available but your SAN was up and running could be costly, planned, or unplanned downtime. To make the services of the server available during planned and unplanned downtimes, we can bring in another server that connects to the same SAN and is up and running before we bring the first server down. In this case, Node 2 will talk with the SAN and keep all operations going while Node 1 is down. This configuration of two or more servers with one shared storage is known as a failover cluster. Here is a Visio diagram from the book showing two nodes in a failover cluster. The failover cluster will work even if one of the servers goes down expectedly or unexpectedly. This is the reason that one of the oldest and most commonly used high availability options is failover clustering. This solution provides instance-level high availability. In other words, every database on your server is protected by the failover cluster. To install a SQL Server failover cluster, you can't just use any hard drive you bought from the local store. You need to have a Windows cluster created with at least one free shared disk resource, often a SAN, to store all of the database files. All incoming connections will connect to whichever node is active. As a matter of fact, to the clients, these nodes will appear just like one call. It won't be able to tell if node 1 is running or node 2 is running. It will look like one giant reliable server. This concept is borrowed from the real customer service world, where we have one point of contact to get our problems done. Let's look at a concept example of this. In this age of IT, the need to give 24/7 customer support is something we're getting used to. If we suddenly find that our laptop has been shutting down the night before an important meeting, well, this is a critical situation for us. It might be 2 in the morning when we call that 24/7 support number immediately for help, and we know someone is there to answer our call. From the support team, we only need one person to do troubleshooting at any given time for a specific customer. When the support professional is done with his or her working hours, they would pass on to the network to the next available support professional. From an end customer experience, the phone line is seamlessly transferred from one engineer to another professional with little or no pause. The helpline that you can call is 24/7 and is really a cluster of support professionals. One support professional no longer being available, but another takes their place. Naturally, we call this a shift change in the human resource world, but in the world of computer and high availability terminology, this is known as a failover. At the end of the shift, one technician fails over for another to take their place. The support professionals in this failover cluster example are the nodes. And all the nodes are using the shared team knowledge to be able to support the call of the customer. We just have one phone number to call no matter which node is taking care of us. The number doesn't change when the shift changes. In the same way, the SQL client is coming in and hooking to a virtual server name which all of the nodes adopt, and it doesn't know which node's taking care of it. As long as it hits that virtual server name, the service is up and supported. In a cluster configuration, multiple machines form a single entity for the application to access data. The application or applications connect to this cluster set using a virtual server name. In this typical setup, the IP address would be owned by one node in the cluster, and this ownership is seamless to the client application that tries to connect. In the case of planned or unplanned downtime, the active node's resources, or the databases, would be moved over to the next node automatically, and the client reconnect to the same virtual server name. This would give the client access to the resources, or the databases. This process is called failover. As in the case of clustering, we need to make sure that the database files are kept on a shared storage that all the nodes in the cluster can access. Any issue with shared storage would be a big problem here. If the storage goes offline, your availability can't be protected by using the cluster. The storage is a single point of failure for this type of high availability deployment. What if you had two critical SQL servers that both needed the protection of clustering? Do you need two clusters, one for each server? Or can you have two SQL instances on one cluster? As part of clustering, we hear a concept called MultiInstance Cluster. This terminology is used to describe a deployment where we have multiple instances of SQL Server installed on each machine participating inside a cluster configuration. Clustering technology is used by other products like Windows or application servers, are implemented for increased processing power via load balancing for better performance. SQL Server clustering is not normally implemented for performance gains. It is mostly a high availability feature at the instance level. SQL Server clustering has been changed in the SQL Server 2012 release and is now called the AlwaysON Failover Cluster Instance, or FCI. And that was Chapter 2.2 on failover clustering concepts. Our next item, Chapter 2.3, log shipping concepts.